Today I want to talk to you about a project called Stratum, and I guess I'm curious to start off on how many have heard of this project. It's relatively new, and I'm seeing about 10%, 20% of the hands in the room. So, well, I think you're going to be very interested in this. I think that NFV and SDN have initiated a transformation in our industry, and we're clearly seeing that now. This conference is a result of that. And Stratum is really going at the heart of the matter, at a lot of the work that actually kicked off and started a lot of what has brought us here today. So, Stratum itself is an open source project, and it's delivering a complete white box solution for next-generation SDN networks. And we're going to talk about all the details of that. These next-generation SDN networks are providing a successor for OpenFlow and what came with OpenFlow. And we've learned a lot with OpenFlow, and OpenFlow has enabled a tremendous amount of disruption and innovation across our industry. But we've also experienced certain challenges, and we're kind of going back to that space and readdressing the challenges and taking the learnings over the last 10 years and doing some things differently. And furthermore, it really addresses the full lifecycle management of a system, where OpenFlow really addressed just one small subset of the problem. The goals of this work are, first and foremost, interchangeability of forwarding devices, to make it very, very easy to swap out different white box switching systems in a network. That was the initial goal of OpenFlow, but we ran into some roadblocks there, and so again, based on learnings, kind of going back and looking at that problem space again. Then secondarily, programmability of forwarding behaviors. And P4 is central to this to a large degree, but it's kind of leveraging the learnings of P4 and the capabilities of P4 itself and reapplying them in the SDN space. And then with all of this, enabling a whole new white box ecosystem. So we think it's going to have a transformative impact on the business as well, not just on the technology. This project that was launched roughly 3 or 4 weeks ago, it was launched with 23, 24 partners from across the industry, which we think is an indication of how important this is. And furthermore, it has all the players from kind of the right places. I'll point out in particular all the silicon players. These are all the switching silicon players for Broadcom, who has a dominant presence today, but a broad spectrum of players, and white box switching players as well. And we're really bringing those two together and creating a new ecosystem in that space. And I think that that's one of the most interesting aspects of this work. I'll point out, too, that Google is at the top of this list as well, along with Tencent, who was recently mentioned. So, cloud providers and telco providers are involved. Google has been formative in the founding of this. A lot of the jumpstart code, the seed source code, is coming out of Google's production network. So Google today runs over 25% of the internet's traffic. Google today runs the world's biggest SDN-based network. Google today runs a network based on their flavor of OpenFlow, and is using much of the techniques and technologies that Stratum is embracing. And so essentially sort of the best case learnings out of Google are seeding this work in Stratum, which I think is also very exciting. So I want to put this in context. And so you understand the scope of the work and where this fits into the bigger picture. Because things move so fast, it's hard sometimes to keep track of all the pieces. So this is a slide that's been around for a little bit, but for those of you who haven't seen it, I think this will help bring you up to speed. First of all, the ONF. The ONF, the body I work for, is an operator-led consortium. I mean, our board of directors is only operators, and it's the operators you see here on the left. Tier 1 operators from around the world who are really the most forward-leaning operators and pushing things forward rapidly. We have over 160 members in total, but this is the leadership base that you see here. The ONF has done tremendous work over the last few years. The ONF is the home of SDN. Is the home of OpenFlow, and then of the ONOS open source controller, and then of the Chord project. And for those of you who don't know, Chord today is sort of the leading de facto open source platform for edge computing, for the edge cloud. I would argue that Chord was the first group to really go after this problem space and sort of formed this, this work around the edge cloud. And at this point in time, a number of analysts who have been surveying operators are coming back with numbers that you see here today. That, on the, that 40% of all subscribers worldwide will be running on Cord by 2021. That 70% of operators are planning to deploy Cord. I have a list of over 20 Tier 1 operators worldwide that are active with Cord. I think we're going into production. I know of one production announcement that we hope the operator will make in the next 4 to 6 weeks. This is moving very rapidly. There's quite a lot going on. But I'm not here to talk about Cord, frankly. I'm here to talk about P4 and Stratum, which fits into this bigger picture, because this is in the scope of the ONF's work, but it's really going back at the foundation that has enabled Cord and enabled all of this other work. So P4 and the P4.org is merging with the ONF and is coming into the ONF umbrella. And the Stratum project is really intended to bring all of this together and to progress forward the work of SDN and of OpenFlow and to create a new next-generation foundation for much of this work that we're doing. So the problem space, if you look at what's needed to manage a next-generation SDN-capable data plane, there are really sort of 4 problem areas. The first is the definition of the pipeline or the forwarding behavior of the ASIC. The second is controlling that pipeline. The third is configuring the device, and the 4 is operational characteristics of managing the device. And the first generation of SDN and the OpenFlow work really only addressed the second of these, the control of the pipeline. The definition of the pipeline, all this work over here, was just implied, or it was in specs that ASIC vendors had that you needed an NDA to even get your hands on. And so, OpenFlow just assumed a certain type of pipeline, and everybody sort of went along with that because the industry was using, generally speaking, one chipset, and that's kind of where things went. OpenFlow focused on pipeline control, but did it in a standards-based way. OpenFlow is a PDF working on defining how to interface. And so, even the notion of software-defined and moving at software speed, OpenFlow was moving more at a standards-based approach to things. And then in the area of configuration, said nothing and just relied on existing techniques like SNMP, CLI, NetConf, and Yang. And so there's not a lot of standardization there. There are a lot of different vendors doing it in different ways. And then in the area of operations, nothing really. And the industry's never really addressed this space very well. So these are all 4 problem spaces, and the Stratum work is intended to kind of go after the full spectrum here because we're after full life cycle management of boxes in an automated way. I mean, think of the scale at which Google is deploying their data centers. They want to leverage this work to be able to take a box off the shelf, drop it in their network, auto-learn, auto-load, take it through its full life cycle, deprecate it, and pull it out of the network, and without humans getting involved at all, in a very intent-based way. And if you heard Vijay's talk, it's all centered on this kind of capability. So to this end, the Stratum work, number 1, uses P4 and the P4 programming language for pipeline definition. P4 is a programming language that lets you unambiguously define the forwarding behavior of a device. It's not standard with ASCII comments about things behave this way or that way. It's it's a programming language, and so it's perfectly deterministic in its behavior. The P4 program can be used to reprogram the data plane itself. So if I just flip back and forth, I'm really saying that the ASICs used to define the pipeline, but with P4 on capable devices, it's possible to redefine the forwarding behavior of the pipeline at runtime in a running production system. It uses something called P4 runtime for the pipeline control. And I'm going to talk a touch more about P4 runtime. At this point in this talk, just try to differentiate P4 from P4 runtime. People conflate the two, but they're really two different things. And then for configuration, it uses OpenConfig. And for operation, it uses GNOI. And so, essentially, we're taking, different elements and learnings over the last few years and bringing them all together in this project called Stratum. So a touch on P4 runtime, because I see a lot of confusion in the industry. So this diagram is sort of what P4 and P4 runtime bring to the table to make a network, a data plane fully programmable. That you take a P4 program, which is a definition of forwarding pipeline, and you run it through a tool chain, and out of that, you get components that can get pushed down to program the network forwarding behavior, but also elements that can go into a controller so the controller can learn how to speak to the data plane. And this is the P4 runtime piece, the controller speaking to the data plane. And this can be updated at runtime. In a running network, you can adjust the P4 program. The controller and the data plane can learn dynamically and can just and be upgraded and continue to operate without being taken out of production. So this is the way people think of P4. This is the natural expectation people have when we talk about this. The important thing to realize is you can flip it on its head. What if you have an ASIC that's not programmable? I mean, 100% of the ASICs deployed in production today are not fully programmable. They look more like this, big complex pipelines defined by ASIC vendors. You can still use P4 and P4 runtime to great effect. So you flip it on its head. Instead of using P4 to push the definition of the pipeline down, use P4 to document the behavior of the pipeline, almost to pull it out. But you can document it now in an unambiguous way. And then you can still use the rest of the tool chain. So you can take it still through the compiler and teach the controller how to speak to the data plane, and in this way still use the majority of this work and build an infrastructure that's forward compatible with programmable data planes, but leverage the ASICs and the systems that are deployed today. The second thing I want to touch on is the benefits of a centralized network operating system. So, and this really connects back to a lot of Google's work and Google's talk from earlier. So that if we have multiple SDN switches that are controlled by a centralized NOS, the centralized NOS gets a complete view of the network state, things like forwarding and configuration state and the like. And with that, you then get a global view that makes it possible to do things like network verification. Again, everything that's connected back to what you were hearing from Google. And network debugging, change management, lifecycle management. And it's upon this that one can then really do intent-based networking. I mean, you need all of this to get to intent-based networking. But with a full view of the network, one can then define policy end-to-end and apply the policy, do things like network verification or verifying a change, simulating a change before you even deploy the change, and verifying the change once deployed and rolling it back if necessary. So we see huge value in the centralized NOS model. So Stratum is a thin switch, white box, open source implementation. It's intended to run as little as possible in the white box switch and have these northbound interfaces that we talked about, the P4, P4 runtime, and the like, and to talk to a network operating system. But it's really important to note that the network operating system here, the way it's drawn here and the way it was drawn on the last slide, the network operating system is centralized and not part of the same system. The NOS itself can actually could co-reside with Stratum in the same embedded system. And you'll see that on this next slide, where there are really 4 different ways Stratum is getting used and deployed. The first is, maybe think of it as the Google scenario, where somebody has their own controller, but they want to run Stratum with all these next-generation SDN interfaces on a thin white box switch. But you can also do it with a full open source stack. So from the ONF, we have a full open source implementation of a next-generation NFV-capable data center. And so it would run ONOS and Trellis on top of Stratum to give one a complete solution, all in open source. Or you can run Cord on top of this stack natively. And I started off talking about Cord and some of the exciting things Cord is doing. Cord will take native advantage of all of this and all of this capability. And we're very excited about that, and we think it's going to make it possible for Cord to do very, very innovative, forward-leaning things. And I'll touch on that on the next slide. But the last scenario I want to get back to actually touches back to the very first talk of the day, where DNOS was discussed from the Viata/AT&T work. We're actually talking with that group, and one can put the control software, the more traditional control software, BGP-like capabilities on the same platform as Stratum itself, and build a more traditional router/switch, and still leverage all the Stratum work. And with this, you get all the benefits of the P4 and all the platform benefits. It'd be very, very easy to port from one white box to another if you use this architecture. And we are collaboratively working with the DNOS group to use this architecture moving forward. And when they talk about leveraging P4, it's using this approach. So, we did something really, really interesting that was an early taste of what this enables. And at Mobile World Congress in Barcelona just a few months ago, that we showed, that the VNF we've come to know, everybody thinks of it as, okay, I run a function on an x86. Well, I think we've learned over time that doing that alone does not yield the economic and efficiency benefits that we were kind of hoping for at the very beginning, that we need, x86s are actually reasonably expensive systems as well, and we need greater levels of optimization to really achieve the scale and efficiency we want. There's been a lot of work about acceleration and NICs and the like. We've heard a number of different talks that touch on elements of that. But what we showed and have shown now using P4 is actually taking elements of the VNF. This is actually from the S gateway, P gateway of a mobile core, and pushing it down into programmable network, aka P4 fabric, and being able to run actually the GTP tunnel termination and all the accounting and everything that's needed for the user plane of the S gateway, P gateway in P4 at 100x the performance of what it would run on an x86. So by taking that functionality and pushing it into the network itself, you just imagine the scale and the disruptive capabilities this achieves, how much more you can fit into a small form factor, the power and space savings and the like. And our view on this is that cloud services are around decomposing problems into small microservices, but then you have to place the microservices where they run best. And an x86 is not always the best place. We have ARM, we have GPUs, we have P4, we have TPUs, we have all kinds of different kinds of technologies that can all run different kinds of workloads much, much more efficiently. And really to achieve the, sort of the great win that we're hoping for with virtualization, we really need to be headed in this direction. Connecting this back to Stratum, Stratum enables all of this. Stratum is really what enables this piece, and what we were demoing and have shown this live is sort of an early POC of this kind of disaggregation. So the goals of Stratum are really twofold. The first is interoperability, which is using P4 and the Stratum environment to create a contract between the network operating system and the data plane. So, and an unambiguous contract. So it's very clear when an operator buys a system exactly what it's capable of. And this contract will be in code, unlike a written standard or unlike an RFP. And furthermore, this project aims to do automated verification of the contract. I mean, since it's in code, it's possible to create a tool chain that can actually test the capabilities of a system to conclude whether or not it really does support what it claims to support. The secondary goal is around pipeline programmability, which I touched on in the last slide. But making it possible, you can think of this as creating highly customized contracts. So instead of an operator putting out an RFP that lists a bunch of standards, you could imagine an RFP including P4 code, saying I need a data plane that can support this kind of capability. And we think that could really have a transformative impact on what's possible in the industry. So the timeline for Stratum, right now it's in what we call an incubation phase. And so project members have full access and others can join, but we expect people to roll up their sleeves and contribute as they're joining. But this moves into full open source. Our expectation is early next year. At that point, it's going to be Apache 2.0, so it's free to use in the most liberal ways. And at that time, we're also expecting a complete ecosystem to be up and running. That means a whole selection of white box vendors with different silicon options, all available with Stratum ports ready to be purchased off the shelf. And then lastly, Google has stated their intention to take Stratum to production this year. And so they're on a very aggressive timeline. It fits pretty well into their architecture. And so they already have some of the infrastructure in place to be able to consume it rapidly, and they're on track to do just that. So just in summary, these next-generation SDN interfaces, what we talked about, yield a bunch of really important things. It's this notion of an unambiguous contract. And secondly, where possible, to make these contracts customizable or programmable. But with this, we think we will significantly reduce the overhead of bringing new systems onto the network. And this is really Google's primary goal, frankly. They have built their own systems today. They want to be able to consume the latest silicon and latest white boxes really rapidly with very low barriers. And then lastly, by reducing this overhead to enable a whole new market of white box systems. And we think the results of this are really sort of the holy grail. Often it's possible to achieve 2 of these 3, but very hard to achieve all 3 of velocity of innovation while reducing costs and increasing reliability all at the same time. And but this has all the elements to achieve that kind of result. So just in closing, the community, we think, we started off, we already have probably about another 4 companies that are in the process of joining, and we welcome others to come and join the community. So please, if you'd like to learn more, please reach out to me. Thank you.